In this video, I'll do a firewalling overview. Firewalls come in either hardware or software form, and their general purpose is to control the flow of network traffic into or out of a network or even the individual host. Now, we can configure our firewalls with on-premises equipment, or we can do it if it's supported by a public cloud provider in the cloud. Firewall solutions from Palo Alto Networks also include virtual machine appliance firewalls that are pre-installed and require only custom configuration. Now, stateful firewalls are designed to track connection state, or sessions, as opposed to each individual packet within the session. Now, this is considered more secure than a stateless firewall, which does just that. It tracks each individual packet and does not have the capability to track a session. All computing devices should really have a firewall solution installed. This includes servers, desktops, laptops, tablets, and of course, smartphones. A packet filtering firewall is one that examines packet headers as seen pictured here on the right-hand side of the screen. So for instance, in this packet header, we see a source and a destination port, a sequence number, an acknowledgement number, which means it must be a TCP header. We see things like header length and so on. So packet filtering firewalls can look at many of these types of fields to decide whether traffic is allowed or denied. So by looking at things like the IP protocol ID, source and destination IP address, as we see in our picture here on the screen, the source and destination port number, maybe the ICMP message type, or additional IP options and flags. A web application firewall is a little bit more detailed because it's designed to really dig a little bit deeper in the packet payload beyond just the headers. It's often referred to as a WAF, and it is specific to HTTP connections, whereas packet filtering firewalls can look at any type of traffic. Another type of firewall is a proxy server. It's designed to retrieve internet content for internal clients that request it, so it's really masking or hiding the true identity of those requesting clients. Another benefit of a proxy server is content that is retrieved can be cached to speed up subsequent requests. A reverse proxy server listens for connection requests, for example, from internet clients for a given network service such as a web server. So for instance, the proxy server might listen for TCP port 80 website connections, and then what it will do is take those incoming connections from the internet and forward them to an internal host, a web server, listening elsewhere, ideally on a different port number. But it doesn't have to be a different port number. Address translation is another way to firewall, where it hides the internal identity of hosts. However, routing needs to be enabled on your translation device, and the hosts that need to use that translation device, for example, if you're going to be using port address translation to get a bunch of clients out on the internet, they need to point to that translation device as their default gateway. Network address translation, often called NAT, means that we've got multiple external-facing public IPs that each map to a different internal private host IP. So we're protecting the true identity of those internal hosts while allowing incoming connections from the outside. Port address translation is often referred to as PAT. This is where we can allow multiple internal clients to access the internet through a single public IP address configured on the PAT device. We then have to consider encrypted traffic when thinking about firewalls. So for example, if packet headers are encrypted, firewalls won't be able to read them. Now there are some exceptions. Some firewalling tools will allow you to inject some kind of a certificate or key to decrypt transmissions. But for the most part, when we talk about encrypted network traffic, it's not the headers that are encrypted. Usually we're talking about the payload or the actual data that is encrypted. We should also consider the use of a variety of firewall vendor solutions to increase security. So for example, if one of our firewalls gets compromised by a malicious user, they won't be able to use that same exploit against another firewall in the enterprise because we'd be using a different vendor solution. We should also consider how we're going to have a central, standardized way to configure and deploy firewall settings to numerous devices. We might do this through scripts, so whether it's a Linux shell script or a Windows PowerShell script. We might even use PowerShell Desired State Configuration, or DSC, to configure firewall settings on multiple devices, including Linux. Or if you're in an Active Directory environment, you might consider the use of Active Directory and group policy to centrally configure the Windows firewall for Windows devices. In this video, we did an overview of firewalling.